The program we write is stored in the hard disk and is executed by the CPU. The read and write speed of a hard disk are far too slow for the CPU. To solve this problem, a storage device called memory is placed between the hard disk and the CPU. Memory has a much faster read and write speed, but it can only store data temporarily. Once the power is off, it will lose everything it stores. When we run a program, the program will first be loaded into the memory. The full name of the memory is Dynamic Random Access Memory. There is also a static type. Static RAM is faster, but also more expensive. It is installed inside the CPU to store caches. Dynamic RAM is where programs are loaded into before being executed by the CPU. It is also one of the most important factors you consider when buying a computer. In the following lessons, when we use the word memory, we mean dynamic RAM. As programmers, we only need to care about how much dynamic RAM space our program consumes during its execution. The memory space is limited, and your program is not the only one that uses it. You should try to use as little memory space as possible. The word random is the key here. Most of the time, we retrieve data from memory in order, but if we want, we can also pick a specific piece of data directly. This is why memory is called random access memory. So what enables us to retrieve data randomly from memory? Let's say this table represents the memory. Each grid represents 1 bit. 8 bits put together is 1 byte. Each byte will be given a memory address. The memory address is just a series of continuous numbers. It is also called pointer, as it can point us to a specific part of memory. Giving each byte a memory address is called byte addressing. Some special machines may use word addressing, where several bytes share one memory address. Byte addressing makes sure every byte is addressable. This is what enables us to retrieve data from memory randomly. But byte addressing also means the minimum storage unit in memory is 1 byte, not one binary digit. If you have a piece of data that is only 1 bit big, it still occupies 1 byte of memory space, even though there will be 7 wasted bits. The memory we have here has 48 bits in total. But under byte addressing, it can only store 6 pieces of data at most, so random access does come at a price.